Howdy, students. I'm sorry if there's background noise going on, but I am outside today. Uh, and I'll try to make this quick, give you enough explanation to hopefully help you out with a little bit of feedback on the work that you're doing, but not take up, a whole ton of time. So here we go. Solving quadratic equations. Here's problem number one. Now, what I'm looking back, as I'm looking back on my work, I'm realizing that really what I should have done here was show the table of values. So you can see that I graphed several points as I approached the x-axis until I found out what my solutions were. In this case, for number one, solution both positive and -3. However, because this is a solve by graphing section, um, in order for me to put this graph together, I did have to create a table of values. Now, I did it mentally. I should have done it on the sheet of paper. All right. I should have done that as part of my work. So if you included a table of values as you found your solutions, awesome. If you forgot to do that like I did, try to remember that for next time. All right. When you're solving by graphing, create that table of values. So number two should be no solution. We have a positive y-intercept and it curves up. So it's never going to cross the x-axis. Number three, we see that basically that is a version of our parent function, just amplified by the coefficient of 4. Therefore, we have a single solution, x is 0. Number 4, solution should be positive and -2. Number 5 and 6, we have no solutions for number 5. Again, positive y-intercept and a positively curving function means we do not hit the y-axis. Now, what I want you to notice on number 5 is I used this symbol to indicate a jump in y values because I knew I was going to have a y-intercept of 16. I could tell that by the function. So I knew, and it was going to curve positive. So I knew that I was going to have 0 data between 0 and 16 on the y-axis. This is the way to appropriately show that on a graph. Please be mindful. If you showed 1 through 16, right, that's a lot of empty space. Cool, that's fine. You don't need to change your graph. But what I want to share with you is that using this break function on an axis is very important. Now, there's been a lot of graphs that have been shared in the news lately, like with the entire nation, with little things like this done incorrectly. Scales are wrong. Pie graphs where all the percentages add up to like 170%. Like graphing's important, guys. So be mindful, understand how to read them, understand how to create them, understand what little symbols like this mean. All right. Solutions for number 6, positive and -3. Solutions for number 7, no solutions. Number 8, one single solution. It's the parent function, so we know the only solution is x equals 0. Number 9, we have two solutions, positive and -2. All right, so now we're done with graphing. All right, number 10, we needed to use square roots to solve. Now, remember, in this case, we're not just looking for the principal square root, we are looking for both positive and negative values if available. So number 10, the roots, what I did to this equation is I just square rooted both sides, and I ended up with two solutions, positive and -7. Here, did the same thing. Here's me indicating the step that I took. The original equation was b squared equals 441. I took the root of both sides. I end up with, oops, dang it. I end up with positive and -21. B, they added a single step, so I added 225 to both sides, took the square root, and found out that the roots were, the zeros of the function were positive and -15. 13, subtracted 25 from both sides, ended up with a parent function. The only root is 0. 14, added 9 to both sides, ended up with the square root of -7. Now, in as far as a real number is concerned, we have no solution when we're taking the square root of a negative number. All right, um, so we're stuck. We're stuck here. Uh-uh. And if you had added 16 to both sides, you would have ended up with x squared plus, what is that, 7? So plus 7, that's a y-intercept of positive 7, and then the x squared is positive, so it curves up. So you knew if you graph this, it would also have no solution. All right. Number 15, divide both sides by 4. I end up with the roots of both positive and -5 halves. Number 16, divide both sides by 64, and I simplify to 1/16. Take the square root of both sides, I end up with a positive and negative 1/4. 17. Add 24 to both sides, divide by 6. I end up with w squared equals 4. Take the square root of both sides. Our solutions are positive and negative 2. 18. 18, I subtract 27 from both sides. I have a negative y on one side, a negative 27 on one side. Multiply or divide by a negative 1. I end up with y squared equals positive 27. Take the square root of both sides. We get the exact answer of plus or minus the square root of 27, or the approximate answer of plus or minus 5.2. 19 are real world problems. We have the area of a square, so that's the problem, and we're trying to find the side of the square, basically. And the first thing you got to do is write the equation to represent the situation that we're given. All right, so area of a square equals side squared. Take the square root of both sides. Now notice here that it's only the principal square root, because a negative 16 meters makes no sense at all. Number 20, same deal. We have to approximate the square root of 90, and yeah, we only use the positive value because negative feet doesn't make any sense at all. Number 21, we have the area of a circle equals pi r squared. Substitute for pi. The second you substitute in for pi, you're approximating. Notice how the equal sign changed to approximately equals. Divide both sides by 3.14, take the square root, and again, do not use the negative value for radius, because negative 5 centimeters in this case does not make sense. So those are all of the exercises. Compare that to what you did. If you found an error that I made, definitely let me know in the class comments, because it's totally possible, folks. All right, have a good one.